Hey everyone, what is going on? Welcome back to another video here on the channel. In today's video, we're going to be taking a look at the comparison between a chart and an electronic speed control. We're going to look at the wire gauge and look at how many amps that is capable of passing through that wire and compare that against the wire that is used in an electronic speed control. Ultimately, what we're going to want to dive into is if there is a difference, why exactly is that difference there? The way that we're going to break down this video in order to explain the subject that we're talking about here today is by first looking at an example and looking up the wiring chart values for that specific example. Then we're going to jump into 5 reasons as to why this might actually be different. Then lastly, what I'm going to do is end with a couple examples that come from the automotive world. So let's get started and take a look at our example that we're going to use here in the video today. This is a Castle Creations 100 amp Phoenix Edge electronic speed control. It's ultimately designed for radio controlled airplanes, being that it doesn't have any sort of reverse on it. What we are after here is ultimately the gauge of wire that is used on the battery side. We're specifically going to be looking at just the 2 wires that are used because we know exactly how many amps are going to be going through this. This is where the 100 amps must be going through when this speed control is rated for that 100 mark. And we want to also confirm that this ESC is truly a 100 amp ESC. So this we've already done. We've already know and established that we can draw 100 amps from this electronic speed control and it'll handle it for an entire duration of a 5,000 milliamp hour battery pack, which is pretty good. And the temperatures were excellent. We had excellent temperatures on this ESC. So all that checks out. We know that this can deliver 100 amps and we know that the wire temperature was good as well. So let's dive into exactly what's happening here. We're going to look at the wire on this electronic speed control and it comes out as a 10 gauge wire. Now a 10 gauge handling 100 amps. Let's go flip over to our wire gauge chart and take a look at what that says. So if we're taking a look at this specific wire gauge chart and we look at the 10 gauge wire, we look at the chassis wiring and it tells us that it's at 55 amps. And if you look at the power transmission for this specific wire gauge, it's very low at a much lower number there. Ultimately, what we want to understand is why is there a difference between the 55 amps that this chart is telling us is the maximum that this wire can actually deliver versus the actual ESC that does deliver 100 amps. And we know that it delivers 100 amps continuously for the entire duration of a battery pack. So we're going to dive into the top 5 reasons as to why this ESC is able to handle having a 10 gauge wire to draw a load of 100 amps. We're going to get into those. Of course, there are going to be many other reasons as to why this can be true, and it actually is true that your wire can absolutely deliver more than what this wire chart is stating. It really comes down to application specific. The specific application that we obviously have is radio controlled vehicles, and that is very different than having a wire that, let's say, runs through some sort of server case or PC case, or maybe wires that run through an attic in your home. This is a very different scenario, as you can imagine, to our radio control vehicles. And that chassis wiring chart needs to be very conservative in order to make sure that it's always safe for all the different applications that you throw at it. If you base your wiring decisions off of this chart, you're going to be more than likely very, very conservative, unless of course you have that environment or that type of application where you're really pushing the wire because you have a whole bunch of stacking factors that need to have some conservative amount of wire being used. So that's a couple reasons I've already mentioned, but not necessarily included in the ones that I want to go through. So let's start off and talk about the first one that I wanted to go through, and that deals with the length of wire. In chassis wiring, you would typically have longer lengths of wire, and you can imagine if you have a bunch of heat coming off of a longer length of wire, you're going to raise the ambient temperature within a case, and that is simply just not so good. When it comes to an electronic speed control, you can see the amount of wire that we have is extremely short. We're only dealing with maybe a foot of wire on one side and maybe a little bit more than a foot of wire total on the other side. However, we only use 2 of these wires at one time. So a foot here, a foot there, we don't really have all that much wire in terms of its length. This is the first reason that we're going to be discussing in terms of why it's acceptable and why it does actually work to pass 100 amps through a wire that is only rated to go up to 55 amps on our chassis wiring chart. The second reason I do want to mention comes down to the cooling that we have within the radio controlled vehicle that we're operating. You can imagine in a chassis wiring type of environment, they, in order to produce this chart, need to make it very conservative. So the assumption essentially is that there is no real good cooling inside of that chassis. However, for radio controlled applications, more than likely in every single application, you're going to have some form of airflow that just happens to make its way to the wires in order to carry that excess amount of heat away from the wires, away from even, of course, the electronic speed control and the remainder of the wires and system as well. If the amount of airflow or cooling capacity is greater than 0, this is going to help that wire being able to carry a more significant amount of current as you are running your radio control vehicle. The third item that I want to talk about is voltage drop. We're not regulated in any sort of way in the radio controlled application for a specific type of voltage drop. You might see in other applications there is code that tells you you cannot exceed 5% or 2.5%, or maybe there's even rules of thumb that you have to follow as it relates to this sort of thing. And to tie on to the back of what we just stated there, we are not necessarily concerned so much about the amount of power loss that we get in those wires. If we're losing a few watts or even up to 30 watts when you're making 7,000 watts, it's not going to make much of a difference to the overall grand scheme of things. This waste heat that we're producing gets carried away. We can remove it fairly easy with the airflow that we have, and we're going to have a good working power system. In some high performance applications where we're running our radio control vehicles for the absolute most top speed that we can possibly get out of a radio controlled car, we're going to see voltage drops in the battery that are just absolutely significant, massive amounts of voltage drop. So having some form of code that tells us that we can only be within a certain amount really won't make any sense for the radio controlled application. But for chassis wiring, it does. And there are rules there for what you should be following. The fourth item here comes down to the actual wire that's used. The wire that's used in the typical radio controlled electronic speed control uses this sort of silicone type insulation jacket around the actual wire. This is a very good quality insulation jacket that's used, and another reason as to why we can actually extract more current through this relatively smaller gauge size. When we look at the silicone specifications, you're typically going to be around 150 degrees Celsius. Anything of a temperature that's lower than that is going to be okay for the breakdown of the insulation material. One of the concerns here is that the insulation material breaks down, and this is where you run into the safety concerns of having some sort of fire. If you break down the insulation on one of these wires as well as another one, then you can actually have these two wires touch with no insulation. Then you get a short, massive amounts of current traveling between those wires, getting extremely hot, and this is where things start to burn up. And of course, you will have the insulation material also beginning to smoke and potentially possible to catch on fire as well. So those are a couple different ways that you can have some safety concerns. However, with our silicone jackets, silicone insulation, we're gonna see anything up to 150 degrees Celsius okay for these. Now, I don't recommend, driving your wires up to that temperature. You do wanna stick to somewhere no more than 60 degrees to 80 degrees Celsius or so. That would be my maximum recommendation. However, more than likely what would happen here is that you will run into an issue with the connector. And maybe even some of you can comment in the section below if you've actually had a solder joint fail and desolder your connector before the wire actually burned. This is probably a little bit more likely than having an issue with the wire itself. Now another point here comes down to the ambient temperatures that we are running. Typically the ambient temperatures in a radio controlled vehicle is not going to be that much higher than the temperature that exists outdoors. But for chassis wiring, this is not actually the case. Your ambient temperatures can be quite significantly higher than the actual ambient temperature in a room or even outside. A perfect example is running wire through the attic. In the attic you could see definitely temperatures of 50 degrees Fahrenheit or even more on peak heat days, and that is quite significant. For this reason, we don't need to be as conservative within our wire that we use on the electronic speed control. That's the 5 items that I wanted to cover. Now what I want to do is bring your attention to some automotive type applications and the chart that is associated with that application. So the first thing to pay attention to here is this is not a general automotive chart. This is something for a very specific application within the automotive industry. And you can see just looking at this chart that the amps are quite high for the wire gauge that is used. Now this chart is definitely accurate for its intended purpose. However, we must know and understand exactly how to use this chart properly, and we don't want to use this chart for other types of applications. So you can see here, drawing a load of 100 to 150 amps, you're going to be looking at like 8 gauge, 10 gauge, that sort of realm of size when it comes down to your wire. Very different than what we looked at for the chassis wiring. The point here is that there are differences in applications, and you can use different size wires for different amounts of load. Another point I want to bring your attention to is if you've ever looked at the size of wire in your car, you would see that the starter motor actually doesn't have as large of a wire that you'd expect. You may find some gauge of wire there for your starter being around the 8 gauge or so. And starter motors are definitely capable of well over 150 amps continuous, essentially being drawn from that specific wire or drawn from the battery pack. And you may even see over 200 to 250 amps depending on what kind of size of vehicle and size of engine that we're actually talking about. And you might want to argue here that the starter motor is only used for a split second of time. And that's true for the most part, but I'm sure you've seen that guy who can't start the vehicle and he's been cranking for 20 to 30 seconds constant. The point that I want to make here is that wire gauge has to be okay to suit all these types of scenarios for this specific application. If it was not safe to do what the companies are doing, we would not be able to put these types of wire gauges on the starter motor right from the factory. Well guys, that pretty well does it for this video. I hope you enjoyed the video. As always, like the video if you do, and don't forget to hit that sub button so that I can see you guys in the next video. Thanks a lot for watching. See you in the next one.